Understanding integers. The target for this lesson is, I can compare and order integers and use integers to represent real-world situations. Let's start with vocabulary. Negative numbers are numbers that are less than 0. The diagram shows negative numbers descending toward the left. Positive numbers are numbers that are greater than 0. The diagram shows positive numbers ascending toward the right.
0 is the absence of a value. It is neither positive nor negative. In the diagram, it is the center between the positive and negative values.
Opposite numbers are numbers that are the same distance from 0 on a number line, but are on opposite sides of 0. For example, -3 and +3 are both 3 units away from 0, but going in opposite directions. Integers are the set of all whole numbers, their opposites, and 0. Absolute value is the distance a number is from 0 on a number line. For example, -3 is 3 units away from 0, so the absolute value of -3 is 3. +3 is also 3 units away from 0, so the absolute value of +3 is also 3. Example 1. We'll do this problem together. Find and graph the opposite of each integer. Problem A. Find and graph the opposite of 2. Create a number line with negatives on the left, 0 at the center, and positives to the right. Place a point at +2. This point is 2 units away from 0. Then place a point at -2. This point is also 2 units away from 0. The opposite of 2 is -2 because each integer is 2 units from 0, but on opposite sides of 0.
Notice that 2 and -2 form a mirror image about 0. This is because they are the same distance from 0, but in opposite directions.
Problem B. Find and graph the opposite of -6. Create a number line with negatives on the left, 0 at the center, and positives to the right. Place a point at -6. This point is 6 units away from 0. Then place a point at +6. This point is also 6 units away from 0. The opposite of -6 is 6 because each integer is 6 units from 0, but on opposite sides of 0. Extra example 1. You'll try this problem by yourself. Graph 3 and its opposite. Pause the video and try this problem on your own. When finished, unpause the video to see if you were able to successfully solve the problem. The answer to this problem is a number line marking 3 and -3. Example 2. We'll do this problem together. Find each absolute value. Problem A. What is the absolute value of -4? The absolute value of a number is the distance that number is from 0 on a number line. Because distance is measured as a positive number, the absolute value of a number is always positive. Create a number line with negatives on the left, 0 at the center, and positives to the right. Place a point at -4. This point is 4 units away from 0. Therefore, the absolute value of -4 is 4. Problem B. What is the absolute value of 3? Create a number line with negatives on the left, 0 at the center, and positives to the right. Place a point at +3. This point is 3 units away from 0. Therefore, the absolute value of 3 is 3. Extra example 2. You'll try this problem by yourself. Find the value of the opposite of the absolute value of -7. Notice that the negative sign in front of the absolute value symbol indicates the opposite of. Hit pause and attempt this example. Check your answer by resuming the video to see if you got the correct answer. The answer to this problem is -7. Integers are used in everyday situations. Positive integers are associated with gains and increases. Negative integers are used when describing losses or decreases. Negative integers are also used to describe something that is below sea level, while positive integers describe something above sea level. Example 3. We'll do this problem together. Write an integer to represent each situation. Problem A. Death Valley, California is 282 feet below sea level. 282 feet below indicates a drop downward 282 feet. So the integer that represents this situation is -282. Problem B. The stock market gained 5 points yesterday. A gain represents an increase. So having gained 5 points can be represented by the integer 5. Problem C. Anna withdrew $15 from her savings account. She withdrew $15. To withdraw means to take out. Her savings account will have less money in it, so the integer that represents this situation is -15. Extra example 3. You'll try this problem by yourself. Write an integer to represent each situation. Problem A. Hans deposited $35 in his account. Problem B. A submarine is 200 feet below sea level. This would be a good time to pause the video. Complete the problems by yourself, then check your answers by resuming the video. The answer to problem A is 35. The answer to problem B is -200.
In this lesson, we will use horizontal and vertical number lines. On a horizontal number line, the numbers get larger as you move from left to right. On a vertical number line, the numbers get larger as you move from bottom to top. On the number lines shown, the integer represented by letter A is the smallest integer marked on the number lines, while point E represents the largest integer marked on the number lines.
Example 4. We'll do this problem together. Complete each statement using the less than or greater than symbols. Problem A. -4 compared to 0. Create or draw a number line with negatives to the left, 0 at the center, and positives to the right. On a number line, the numbers move smallest to largest as you move from left to right. Plot the points -4 and 0 on the number line. Since -4 is to the left of 0 on the number line, -4 is less than 0. Problem B. -3 compared to -5. Plot the points -3 and -5 on the number line. Since -3 is to the right of -5 on the number line, -3 is greater than -5. Problem C. -6 compared to 7. Plot the points -6 and 7 on the number line. Because -6 is to the left of 7 on the number line, -6 is less than 7. Extra example 4. You'll try this problem by yourself. Complete each statement with the less than or greater than symbols. A. -7 compared to -5. B. 0 compared to -2. Pause the video and try these problems on your own. When finished, unpause the video to see if you were able to successfully solve the problems. The answer to problem A is -7 is less than -5. The answer to problem B is 0 is greater than -2. Example 5. We'll do this problem together. The 5 states with the lowest temperatures on record are shown in the table below. List and graph the temperatures on a number line from least to greatest.
In the previous example, we used a horizontal number line. Let's use a vertical number line this time to represent the temperatures. When the temperatures are graphed on the number line, the lowest temperature will be furthest to the bottom. The highest temperature will be furthest to the top. I notice that -80 is our smallest integer, and -61 is the greatest. So let's start our number line at -55 and decrease by increments of 5 degrees until we get to -80. Now we can plot each point on the number line. -80. -69 is just above -70. -61 is just below -60. -70. And -66 is just below -65. Now that we've plotted the points on the number line, we can easily write them in ascending order. Listed from least to greatest, the numbers are -80, -70, -69, -66, and -61.
Extra example 5. You'll try this problem by yourself. Gina recorded her elevation in feet at 5 places during a hike: -20, 37, 0, -54, and -5. List her elevations from least to greatest. Hit pause and attempt this example. Check your answer by resuming the video to see if you got the correct answer. The answer to this problem is -54, -20, -5, 0, and 37.
Consider this. Why is it important to have both positive and negative numbers to describe real-world situations? What do you think?